Hello everyone. In last video we discussed about the self-induction, coefficient of a self-induction, as well as we discussed about the mutual inductance and coefficient of a mutual inductance, as well as we did the derivation and we discussed about the SI units of that constants. So now today we are discussing about the mutual inductance of a two long solenoid coils or coaxial coils. So here we have a primary coils P1 and P2 and secondary coils are having S1 and S2. So here the radius of the secondary coil is greater than that of primary, but both primaries and secondaries are having a length L and number of turns are present N1 in primary and number of turns present in the secondary is N2. We know that the flux generated in the secondary due to the primary coil phi 2 is directly proportional to I1 and phi 2 is equal to M into I1. So M is a coefficient of mutual inductance and we are taking this as equation number 1, and we know that flux generated phi is equal to B into A cos of theta, but here we are taking cos 0, that is 1, and here the flux generated in the secondary and having coil N2, so I multiplied this N2 into B1 into A1. Why I took here B1? Because due to magnetic field which is present in the primary, so that is linked with the secondary. So flux is generated in secondary due to first coil. So phi 2 is equal to N2 B1 into A1. This equation we are taking it as a second, and magnetic field at the center of this coil or solenoid is B1 is equal to mu naught N1 into I1. This is the magnetic field at the center of the solenoid, and here we know that B1 is equal to mu naught. This turn density we can write it as a N1 upon L into I1. L will remain same because length of the primary and secondary coils will remain same. So we can write this and we can take this as equation number 3. So we can put 3 in equation number 2. Okay, so we can write here phi 2. Phi 2 is equal to N2. B1 we can substitute here as a mu naught N1 I1 upon L into A1. Okay, so we can write it as a phi 2. So this is what I got the equation. So this phi 2 you can compare with the equation number 1. Suppose if we are taking this as a 4, so compare 4 to equation number 1. So here phi 2 is nothing but M into I1 is equal to N2 mu 2 N1 I1 A1 divided by L. So I1 and I1 get cancelled and you will get mu M is equal to N1 N2 mu naught into A1 divided by L. So this is the coefficient of a mutual inductance in the long solenoid. We are getting it as N1 N2 mu naught A by L. Okay, suppose if instead of air, if they introduced any medium, okay, so we can write this equation as M is equal to, instead of mu we are writing mu M. Okay, so permittivity of the medium N1 N2 into A1 or A divided by L, and we know that epsilon R is mu R is nothing but mu M upon mu naught, and we can write here M is equal to mu naught M. We can rearrange here mu naught M is equal to mu M is equal to mu naught into mu R. So we can write here mu naught into mu R N1 N2 into A1 divided by L. So this is the expression if any medium is introduced in the solenoid. Okay, so this is the special case, and this is the coefficient of self inductance in case of solenoid, long solenoid, and this is the entire derivation for mutual inductance of a two long coaxial coils or solenoid. I hope you understood these videos. Thank you.